Hi, so this is our AES encryption program that uses harvested energy. So the goal of this is to be able to save the state of the program between times in which the board may lose power, since it's running off of harvested energy rather than a consistent energy source. So to do that, we needed to figure out a location in the board's memory that we could save information to that would not be erased when the board lost power. So we selected the flash memory, and we used the main memory region of the flash. We looked at the memory map and all the documentation for that for our specific board, the MSP432 401R. So down here we define our location that we're going to write to, and then we define our write to flash function, which uses a built-in driver_lib program memory function, but we also manually unprotect and erase the sector and then protect it again, just to ensure that everything works as we intend it to. And for our specific location in memory, we had to specify the memory space as bank 0 and flash sector 31, just because that corresponds with our specific location in memory. And then for our main function, we go ahead and initialize the board and initialize AES. We're using tiny AES, and that's the same as previous projects. And then we set our LED light to green so that we know that it is still working on encrypting things, and it will turn blue once it has completed all of the encryption. So then we go ahead and read in a value from the flash memory that we have saved previously to the iteration counter. So what we're writing to that area in memory is we're writing the number of times that we have already encrypted. So our goal is to sort of do like 100. That's not very much data, but just for demonstration purposes, we set it to be 100. So we go ahead and read that in, and then that will be the value that we left off at. And so we know how many more iterations we need to do to complete and get to 100. So if it's more than 100 already, we go ahead and set the counter to 0. But assuming that it's not, we carry on and we run our test encrypt function 100 times. And every 10 iterations of this, we write the current iteration that we're on to flash. So that's like our way of saving state periodically. And then after that, we'll set the LED to blue, assuming that we've completed all 100 times, and we'll set the counter to 0 if the encryption was complete and write that to flash so everything's reset. So basically the idea is that by writing our counter value to the flash memory every 10 iterations, the next time the program starts up when the board has enough power, it'll be able to read that in and start off from where it left off and continue on to get to the 100 completed encryption cycles. Our board is attached to the energy harvesting device, and the power supply is a couple feet away. The light should turn blue whenever it finishes encrypting, and it'll turn blue here in just a second. We have to time skip because it took a little bit longer, but yep. So that means our AES encryption is done.